Zarafu, and it's pretty much all I can do with Australian accent. My original accent is from Romania. I was lucky to work with great people in Australia on a collaborative cluster on urban transport, climate change and health. And my research project was part of one of sub-projects, and I got a scholarship. We are looking at PRT, not only PRT, we developed different land use and transport scenarios for Sydney in particular, with focus on greenhouse gas emissions and energy consumptions and health impact. But today, I would like to talk more about a potential application of PRT systems in edge cities. So before presenting my findings, I would like to talk a bit more about the concept of edge cities, which are actually newly urban centers, also known as technoburbs, urban villages, and other 40 terminologies. The term edge city was coined by Joel Garreau in 1991, and he identified 5 common characteristics which would classify a center and an edge city. And pretty much they are typical for North America, but recently research identified this urban form in Europe and Asia Pacific context. They are concentration of employment developed around major transit nodes, so they have more jobs than bedrooms. They have more than 5 million square feet of office space and more than 600,000 square feet of retail space. And they have grown and changed completely in the past 30 to 50 years. As I said, Garreau identified about 200 centers in the United States falling into this category, edge cities. The most known one, the classical edge city type, is Tyson Corner in Washington. Also in literature, in Europe, Kista can be considered an edge city, Marseille-Saclay. It's very funny because everyone named this urban center Silicon Valley of the region, including Macquarie Park. Seeing Silicon Valley is nothing to compare with. They have a few, characteristics, the same urban form, like large building footprints, very unfriendly for walking and cycling, very highly car dependent, although they were built around major transit centers, like rail stations, pretty much. This is Tyson Corner, and I read recently, Tyson Corner actually had a project a few years ago looking at a feasibility study of PRT system. But they decided to go now for revitalizations, and what I noticed, they will build another underground 4-level car parking in addition to existing 4-level car parking as an answer to high car dependency, which I think is not exactly the right way. Now, Macquarie Park, it's I don't have, so it's in northwest part of the Sydney, about 12 kilometers away from the CBD, 20 kilometers from the airport, and it has been identified by all recent metropolitan strategies as a very important regional center, economic center, and it aims to be Australia technology hub. Now, as I told you, we actually identify all the 5 characteristics of edge cities as per Garo's definition with Macquarie Park. You can see here the checklist. The corridor is the one in the middle, Macquarie Park. So the corridor is served by 3 train stations. The rail line was built in 2009, and you can see on the top right a graphic showing a big increase in rail patronage immediately after opening, but because the fares were free. As soon as they introduced the fares, the mode share dropped dramatically again to 4%. Why is this? When we compare with other centers, we can see a very low accessibility level of train stations. We have train stations there within a 5 kilometers long distance, but to walk from the train station to your university or office, it's pretty difficult. It's very hilly, long distances, long blocks, so no one walks, everyone drives. So we have currently 87% car trips in the corridor. Macquarie Park is well known for offering office space at better rates compared to other centers. But what is interesting is a parking study identified that actually we have 31,000 off-street parking spaces for about 32,000 employees, so it's pretty much 1-to-1 ratio. The center, it's pretty successful from an economic point of view, with predicted growth from 32,000 employees to almost 78,000 by 2031. It houses a big university, Macquarie University, which expects to double the number of students, up to 42,000 students. It has a big shopping mall, all big names in high-tech technology in Australia, they moved there. Okay, so we started kind of environmental urban contest. We have these edge cities, newly urban sub-centers at major traffic nodes around airports, shopping mall, business parks, car-dependent, congested, and we have PRT, which is a passenger transit on-demand system with proven successful applications around airports and business parks. So everyone agreed, okay, let's include PRT in a future scenario. So we developed we developed 4 scenarios, but I will talk today only about 3. Do nothing means business as usual scenario, like projection of existing trends over the next 20 years. Do something, it's what local government and state government plan for the area. They have an ambitious 40-60 split mode share without any plan how to get from 87 down to 60. And we look at different alternative scenarios, but all of them included PRT as a local access feeder, so system for the existing train stations. And when we analyze the environmental impact, we look at traffic, air pollution, energy use, greenhouse emissions, and we did a separate study about urban impact. The assumptions were land use assumptions, the existing assumptions, and transport network. It's pretty much what is planned for the area, and they already started to deliver. The government started to deliver this. We work on a trip forecast by 2031. As you can see, we expect 278,000 trips per day, which is huge. I'm not going into detail how we work with this mode share assumption. However, they were very detailed. We were looking all-purpose trips, not just journey to work. Because every other trips, education trips, shopping trips, business trips are as much as important as and actually they are over 50% represent of total trips. We developed, we are very cautious regarding PRT. So again, PRT was designed as a local access system, as a feeder for the existing rail stations. The mode share assumptions were somewhere between 2 and 5%, with a maximum of 8% for education trips, considering existing examples of Masdar and Virginia University, where the system is pretty successful. These are home-based trips, split, I'm not going, okay. And I designed a network using ATC City Mobile software, which was provided by Professor Martin Lawson and Dr. John Len Millers from University of Bristol, which is pretty much a simplified version of what they have at Ultra. So we have 20 stations, 17.8 kilometers, one single way loop, 70% elevated guideways, stations from with 2 from 5 berths, because this is what the software allocates. And also the software allocates maximum 300 vehicles per stations in and out. In real world, you know, you can have different numbers. And the software doesn't optimize the fleet size, so allocates as many vehicles as required to minimize the waiting time. The software can work with demand matrix generated by the software using a gravity model or a manual origin destination matrix. So we design origin destination matrix for morning peak, afternoon peak, and inter-peak. And then we run simulations in real time for 1 hour morning peak, 1 hour inter-peak, and 1 hour afternoon peak. And here are the results for peak and off-peak hours. And pretty much the simulation confirm what you find in literature. So a really, really good performance. Like in IM peak, 90% of passengers, they have to wait less than 1 minute to be served by vehicles. Vehicle maximum waiting time is about 3 minutes. In PM peak, which is afternoon, is not a problem. We have huge waiting times there. What else? And the fleet required, so to estimate the fleet required for the predicted capacity, we run a 10-hour simulation. The result was 219 vehicles for servicing 39,000 passengers within 10 hours. Then, in order to compare, because it was really difficult to compare, we say, okay, this is a local access system. Let's see the results if all these trips were made by car instead of PRT. And we are very, very cautious and conservative regarding PRT assumptions. So these 390 vehicle fleet numbers, they actually can serve 39,000 passengers, not 32,000 passengers, which was the demand. And you can see we need 11,100 personal cars to provide the same capacity. Okay, and then We calculated vehicle kilometers traveled, and we used existing data from energy use. And also we assumed that by 2031 will be a 10% reduction in energy use from the cars, and no improvements to the existing PRT systems. For air pollution, now to understand is not, this doesn't reflect the local access system. So we looked at the entire trips generated by the corridor, that 278,000 trips, in 3 different scenarios at what this will mean in terms of pollution, of noise, of greenhouse gas emissions, of energy use. And as I said, we assume that everything will be improved other than PRT. So PRT was considered at the existing performance levels. For greenhouse gas emissions, we consider the 2010 levels, or a very ambitious 25% reduction by 2031, which with the existing Australian policy, I don't think they will get there. For urban impact, we estimated just only the floor space required for building new car parks, new car garages, I understood this is the term in the United States, to service that estimated car number trips. Okay, so we didn't consider the land saved by, building PRT structure versus land. It's purely what will be if we have to build car parks for every single scenario, business as usual, planned scenario, and a local access system using PRT. And as you can see, cost in a business as usual scenario, cost of building new car parks in addition to the existing one, it's $2 billion. In a planned scenario, 1.3. Okay, and then we compared all the scenarios, the local access with PRT versus business as usual and versus planned. And you can see here air pollution impact, 33% reduction compared with a business as usual, savings on emissions, 55% floor space saved from building structured car parks, and $1.1 billion avoided cost. I have few images here of PRT systems and guides from that time. Okay, so PRT impact. The simulation shows that we can service 3,800 passengers per hour. We can save 35,600 tons of CO2, 740 tons of monoxide carbon, oxide nitrogen, particulates, sulfur dioxide, and 890 square meters floor space, and 1.2 billion. And Garo has a nice definition of a beauty contest, an attempt to inject quality of life into an edge city. And the winner is Google car. And if I have another minute, I'll try to run the simulation, if I can find it. I saw today another simulation, so this will be nice to see. Okay, so The green dots are full vehicles, the red ones are empty vehicles, and you can see the blue circles are stations, and you can see the base. So this simulations runs now with origin destination matrix for 1 hour IM peak. And the colors here, the red colors means we have 4 pods parked at stations 1, for example. Station 1, so the big circle, station 1, station 10, and station 20 are near to the train stations in Macquarie Park. And this is all.
Okay. Thank you very much, Mike.
Thank you.